Hello everyone, let us dive into our LeetCode daily coding where we are supposed to go through integer break where we receive as input an integer n and we are supposed to break it into the sum of k positive integer where k is actually greater or equal to n and maximize the product of those integer. This is all about the statement. We have an integer n and we are supposed to break it down into k positive integer where k is actually greater or equal to 2 and maximize the product of those integer. Let me give you some examples so you understand where we are going. Let's assume we have an integer 2. We have just one possible solution of breaking, which is 1 and 1, because we want k to be greater or equal to 2. And then by breaking into 1 and 1, the product is 1, so there is actually no debate here. We return 1. Now let us dive into a more complex situation like this where we have 10. Why is this complex? Because let us take even k is equal to 3. Given k is equal to 3, we can have 8 plus 2 plus 0, we can have 7 plus 2 plus 1, we can have 3 plus 3 plus 4, we can have 5 plus 3 plus 2. So those are the elements of length 3 given 10. We can also take size of 2. We are going to have a lot of combination. We can take size of 3 or 4. We are going to have a lot of combination. Now the question here is, how do you make sure that, or how do you organize yourself to get the combination that is going to lead to the maximum product? Okay, so for that we are going to make an observation. So we are going to use a mathematical principle which is saying that to maximize the product of sum of integer, it is important, or you have to make them as close as possible. So what does that mean, making them as close as possible? Let's say we have a given value k equal to 3. I'm taking 3 because it's the example I have here. Let's say we have an integer value k is equal to 3. To make them as close as possible, you have to make sure that the difference in between all of the element of the set, I would say, is actually as close as possible. Let's take this one for instance. We have 8, 2 and 0. The distance in between 8 and 2 is actually 6. There's a big gap in between those two, and there's a big gap in between those two also. Yet the same, there's a big gap here, whereas here you can see that there is no big gap in between those elements, and there's only one gap in between here, and there is actually no way you can make those elements closer than this. So now that you know that you have to make them closer, the next question you have yourself is how to make them closer. That is the next question. Now, for me to make them closer, what I'm gonna do is that I'm gonna say, okay, if I have a n, if I know n and then I know k, I know that to make them closer, I need to have only two possible values: the lower values and the upper values. The lower values are actually the one of n divided by k, and then the upper value, let's say I have n equal to, maybe let's take a big number, maybe 18, and then we want to divide into k equal to, let's say 4, right? You want 4 elements. Now you're gonna say 18 divided by 4 will give you 4 point something, right? So you have 4 here, you will have 4 here, you will have 4 here, and then you have 4 here. When it is giving 4 point something, that means there is a rest. Now what is the value of the rest? The rest is actually 18 modulo k. So 18 modulo k in the other hand will give you 2. Now those 2 means that when we are divided 18 by 4, you have a 2 left, and those 2 can actually be shared in any of those 4 elements. So we can give 1 here and 1 here. This will give us 5 here, 5 here, 4 here, and 4 here. So the closest element we can have given n equal to 18 and k equal to 4 is actually this combination 5, 5, 4, 4. So with this, we are 100% sure that with a given n and a given k, we can have the maximum possible value. Now that the k is not actually a static value, we need to look through all the possible value of k and find out what is the biggest, right? Now, given that we are going to look k from actually 2 till n, right? Because you can't really have k which is greater than n, and I'm just realizing that I don't even need this, so just a simple n here will be okay. So what we have is that we are going to look k from 2 to n, and then we are going to evaluate the maximum possible of that position. And after evaluating the maximum of that position, we are going to compare to the previous maximum and then keep the marks of the previous and the current marks, and at the end we are going to return the marks. So what will it look like? So the first approach will look like this. So you have like your first integer, your first possible result, which is 0. Now you are going to loop from 2 to n because you want to loop through all possible k, and for each of them compute the marks at that position. And then, like we just explained here, we have first of all the minimum. So you compute the minimum, which is n divided by k, which gives you the lower element of the set. Now you have the rest, which denoting the n modulo k, which denoting the number of elements you will have to share if you have to add to the minimum. Now that you have them, now you are going to loop. You are going to have this term. This term is actually the element that you are going to use for the product. I'm starting it at 1 because I know that the product of any element times 1 is actually that element. That's why I'm starting at 1. And now you are going to loop from 0 to k because you know that you have k element, and among those k elements you have rest element, which are going to be me plus 1. So if we still have possible rest, we first take the rest plus 1 and then we decrement the rest. We are going to do so until we don't have any rest element, any remaining element. Now the next operation we are going to do is that we are going to say temp. We now take his value time me. So what does that mean exactly? That means when I'm going to be here, I'm going to have the initial value as, let me take this color. I'm going to have the initial value as 1. This color is not nice. So I will take the initial, cool. I will take the initial value as 1. So now I will loop. I will say, okay, I'm here. Do I still have something in the rest? Initially, the value of x is 2. Do I still have something in the rest? Yes, I have something. So I will say this one will take its value time me plus 1 because I have something in rest. So I will say time 5. And then I will decrement this. So this one will not be 2 anymore. It will be 1. Now I will come back again to the loop. I will say, now I'm here. I will say, do I still have something in the rest? Yes, I have something in the rest. So the result will now we take a previous value time me plus 1. That means time 5. And I will decrement the rest. I will decrement the rest, now is 0. Now when I will be here, I will ask, do I still have something in rest? This one is actually no because I have 0 here. And now I will take time 4. And the same here, it will take time 4. So at the end of this, you have the maximum value of a given k. Now you are going to ask, okay, is the maximum that I have now actually lower or equal? Is actually lower, or is it greater than the previous maximum we're having? You are going to keep the max here, and then that is the max you are going to return here. Now that we are here, there is an observation we can do to get rid of this if loop, of this for loop. We can see that the number of upper element for me are the me plus 1. The number of upper element are actually rest element. That means if the rest is actually equal to 4, that means you are going to have 4 upper element, and then the rest are going to be lower element. Since we already know it advanced how many lower element we are going to have and how many lower element we are going to have, why not making use of it rather than just using a for loop? So that is the idea we are using here. We know that we are going to have rest me plus 1, and the rest are going to be me. So we are going to say power of me plus 1. So me plus 1 is the upper element. We know that it's going to appear rest time, so we just compute the power of this, which actually help us to avoid the for loop. And then we are going to compute the power now of the minimum time of k minus rest, because we know that we have k element. If this one is rest element, this one is definitely k minus rest, and then we continue with the same line we're having here. So this optimization is just to reduce the fact of using a loop, and at the end of the day both are actually solving the problem within 0 seconds. So we can submit and see. It is strange that it is now giving you 2 seconds, whereas it was giving 0 second. You see, add 0 second more than twice. I don't know what's happening, really curious, but it still solved the problem. So this was my approach of solving this. I hope you do enjoy it. Feel free to leave me any message, any question related to this. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.